We'll go ahead and start a little early. Wait till it's okay.
Hello! Look who I got. This is why I wasn't here last week. I'm gonna give her to the attendant here so I can get busy.
You didn't say who she was.
Oh, this is Emerson Errol Watson Keith.
And she's very asleep.
Come on in.
Hi.
When we stopped last time, we were talking about how to manipulate the objects that we draw, especially the cube, which is what we've been working on. And I have written on the board over here the elements of design. If you remember, they are point, line, shape, texture, and color. And right below that are the three basic geometric shapes that you learn how to draw and then manipulate. So draw, manipulate. So we're going to rehash the manipulation of the cube. First thing I'm going to do is draw a picture plane. In fact, I'm going to draw two picture planes. And I'm going to set them up in a normal situation, which means that 1/3, 2/3 for the horizon line. One-third, 2/3, and establish the line of sight vanishing point. And this is 24 inches. And this is 6 inches. And this is 12 inches. This is different over here, but it doesn't matter. I'll still make it as normal as possible. Line of sight vanishing point. Now in this one, let me erase this. Let me make this one a little bit. What I'm going to do is drop this down the width of the picture plane. Go from here to here. This is the station point. If this was 12 inches and this was 6 inches, which would be normal in your drawing pad, this would be 24 inches. And if I draw a line at 45-degree angle to this line right here, it should establish a vanishing point out of the picture plane, which you can't see. If I would draw another one over here at 45 degrees, I'd have a 90-degree right here. And where it intersects the horizon line here is where your vanishing point would be for a two-point perspective. Now over here, what I'm going to do is I'm going to move my station point from the width of the picture plane to half the width. In other words, this is 12 inches, this would be 12 inches. So what I'm doing is I'm moving my picture plane from here to here. So that would give me a vanishing point here and a vanishing point here. Now, I'm going to move up on here and draw a box in 2-point perspective. And I do that by drawing the front edge and using these vanishing points left and right. This is vanishing point right, and this is vanishing point left. Finish drawing the block. And this is a block or a cube in 2-point perspective with a half the normal viewing distance.
Maybe the pictures.
I'm going to do the same thing over here. So I've drawn the same thing, but look what happens when you spread those vanishing points out. You see this angle here, and this angle here. This one is more. This one is more distorted. So this is a wide angle. Two-point perspective block drawing. Now I'm going to erase this one over here. Both of these, by the way, are correct. In other words, this drawing over here was correct, and this drawing over here is correct. This one is just distorted. But what's nice about this one is my vanishing points are on the page where I can see them, and I can use my 18-inch ruler with the setup we've got going. Now last time, the ambient, I never had these kind of ambient noises when I taught before, so you can probably hear Emerson in the background. I'm gonna make my picture plane a little bit larger because I'm gonna start manipulating. And I'm going to stay in 2-point perspective. Now, remember, in 2-point perspective, what you usually do is just draw the front edge. If I was in 1-point perspective, what would I draw? I would draw a square or a rectangle. It's the same true proportion and true shape. Now, all my vanishing points, or all my parallel lines, are moving away from the picture plane, and they're moving to my right. Over here, they're moving to my left. Remember these are construction lines. Construction lines. So I'm going to arbitrarily just draw a vertical here and a vertical here. Remember that these are parallel to in the side view, these are verticals, so they'll be parallel to the sides of the picture plane. So those are easy to draw. Now last week, I used this trick right here. It's called Xing the square or rectangle. And whenever you X the square or rectangle, you actually find the center point of that square or rectangle. In other words, this is right in the middle of this rectangle. This is right in the middle of whatever this shape is, this rhomboid. Now, if I draw a line through that point to this vanishing point over here, it cuts this line in half. 1/2, 1/2. If I draw a vertical, it cuts this in half. Now, if you measured this line here would be shorter than this line here because it's in perspective. In other words, it's further away from you. Now, what I want to do is make a step. Just make a step. And I'll do that by first erasing these lines right here. And draw construction lines that vanishing point over there. And the construction lines that vanishing point over there. And a construction line over here. Now I'm not going to draw it all the way back because I'll be getting too many lines in the drawing. I'm going to draw this one vertical right here. Now I'm going to change the construction lines into emphasis lines. So what I did was to cut out a section of this block. I'm going to get a little big. I need to get bigger. This is construction vanishing point left. This is construction vanishing point right. This is line of sight vanishing point right here. Okay, by the way, where is this? Where am I starting to draw this? Where is this located in terms of me? In other words, I'm looking through my picture plane. Where is it in relationship to me? It's right below the line of sight vanishing point, so it's right in the center. So anything on this side is to the left of me. Anything on this side right here is to the right of me. Now I'm going to arbitrarily finish drawing this cube. Construction lines, emphasis lines. Now what I'm going to do is X this and draw a set of parallel lines over here which cuts this in half, and a vertical line which cuts that in half. Then I'm going to X this one right here. And I'm going to cut that one in half. I love the sound of this. So what I'm going to do now, this is going to be really small. So now what I did, I just X'd the squares that were there. So I cut that in half again. So now I have 1, 2, 3 steps.
4 steps.
4 steps. Yeah, 4 steps. Now I'm going to get rid of this because I want to cut this out. So I no longer want that. Now, all the lines on this side of the block are going to be going to that vanishing point over there. Now, it's a lot easier if you have a ruler. In other words, if you set up your drawing pad and you measured up 12 inches here and 12 inches here, 12 inches here, and drew your horizon line, and establish your vanishing points and label them. Line of sight, vanishing point, and drew a cube, and then did everything that I just did. It should look something like this. Now, the reason I'm having you use a ruler now is because you get this muscle memory thing going for you. If you notice when I draw, I know where that vanishing point is over there, and I draw toward it. See, I draw toward it. And when I cross over here with this line, I have drawn the top of that step right there. And if I start here and draw over here, in other words, I just muscle memory, I know in my mind where it is. And if I draw vertical here, I will draw the front face of that top step. The next thing I'm going to do is draw the top of the second step from the top. And I go over here and go over there and draw the top of that second step. Now I draw the next face. It's just going through the motions now. You just got to know where you're going and what lines are parallel. Now the top step of the third one. And there I have a cube with 4 steps. 1, 2, 3, 4. How many shapes do I have there? I have 1, 2, 3, 4, 5, 6, 7, 8, 9 shapes that make up this image. And it's all correct. It's all correct. Now, anytime you X something, you cut it in half. So that cuts it in half, that cuts it in half, that cuts it in half, that cuts it in half. What if you wanted an odd number? What would you do? I just walked off the screen. I didn't have to worry about this when I lectured in college. So if you hear me talking over here somewhere, just listen for me. Now I'm going to erase this. And I'm going to now whenever I did this in college, it starts looking like I'm doing math, but I'm really not. I'm doing geometry. Now, here's something you need to know. If I take this line right here, the leg of a triangle, a right triangle, and I divide it in 3 equal sections. In other words, this section is equal to that section is equal to that section. And I draw a line through that parallel to this line over here. It will divide this line up into 3 equal sections. Keep in mind parallel, okay? If I have a diagonal line here, and I want to divide that diagonal line up into 3 equal sections, if I do a construction line, and this is a construction line here, and I draw that construction line through the front edge, and divide this up into 3 equal sections, let's say I used an inch. I just randomly drew this. Now what I've done is I've drawn this line in perspective. This is the line in perspective. This is the construction line. Divided up into 3 equal sections. Notice that this line, this line, and this line are parallel. So if I start here at A, start here at A, then I draw a line through the end of that and extend it out. As soon as I hit the horizon line back there, I establish a construction vanishing point where all parallel lines go to. So if I draw a line from here, through here, and here, through here, it will divide this line up into equal number of sections in perspective. Now, are they equal? No. Why aren't they equal? Because this is moving away from me, so it gets shorter as it moves away. And I know this is correct because of this. Because of this. Don't have to think about it. Whatever I want to do. Now, what if I made this into 3 equal sections here? 1, 2, 3. In other words, 3 little equal sections here. Well, I can make that any size I want to. These equal sections any size I want to. So I would, if I was going to use these 3, I would go from here up to here. You get a construction vanishing point. And I would draw from that construction vanishing point down through here and down through here. And wherever it crosses here, it'd be the same. It crosses at the same point. The only thing I'm doing is I'm just changing this angle here. As long as they're equal, and I establish this construction vanishing point, it will divide this line in perspective up into equal sections. Okay, so we're going to do that. We're going to draw a block in 2-point perspective, distorted, and we're going to cut 3 steps out of this. I'm going to cut 3 steps out of this. So, I'm going to use a construction vanishing point here, get 3 equal sections. I'll make them smaller. 1, 2, 3. Okay, so my construction line is here, construction line is here. I go from the end of this known 3 equal section line through this line in perspective, and I go back to the horizon line and get a construction vanishing point. And I go from there down to here, down to here, and so I have 3. This is divided into 3 equal sections. Now I can draw my verticals. Like that. Now, if I draw a diagonal across here, guess what happens? It divides this vertical in 3 equal sections. So I can now start cutting steps out of this thing. I have this line here, this line here, and that line there. In other words, this is what this end of the block would look like, cutting 3 equal sections out of there. Now, I got everything's there now. I use that vanishing point over there, get the top of this face, draw vertical, go from here to that vanishing point over there, I get the front face of that top block. Now I know if I go from over here, I'll start the front of the top face of the next step down. If I go over there, I'll draw the next top face, and then I go straight down, over there, over there, over there, down. So now I've drawn a block with 3 sections cut out of it. 3 sections cut out of it. It would be nice if you guys would write me and say, hey, I don't understand what you're doing. Can you go over that again? I want to get a little more complicated here. And then, what I'd like to do is start out really, really simple and then build on that. Now, in this situation I've got going here, I have a line of sight vanishing point right here. And my station point is right here. Remember, I moved the station point in really close like this, so I can put my vanishing points here. Now, do you remember me telling you this? Whenever your vanishing points are equidistant apart, in other words, from this central vanishing point, this object that you're looking at, and I'll draw a top view. This is looking down from the top. This is my line of sight. Where was I going with this? Oh, I know where I was going with this. I'm going to draw a perfect cube. This is my station point. Now, if I measure from here to here, I'll be measuring from this vanishing point right here to here. If I measure this, and use this and get a distance. Let's say this is distance A, and then drop an arc or swing an arc, whatever you want to call it. In other words, I measure out here that distance. I've got a construction vanishing point over here, and I do the same thing from the other side. I measure from there to there and drop an arc up here. This would probably be a little further out than that. This is construction vanishing point right. This is construction vanishing point left. What I'm doing is I'm getting ready to use the fact that I could show you the geometry over here, but it would just confuse you. Just do this because it works. I'm going to be drawing a perfect cube is what I'm going to be drawing. And what I'm going to do is draw the front edge of the cube and go ahead and draw it in. Draw the tracer lines over here and the tracer lines over here. Now, if I take this vertical measurement, and lay it horizontal to the bottom picture point, and I go from here, this is to the right, to this construction vanishing point over here, this line right here is the same length as this line right here. Using this construction vanishing point. That's the geometry of it. You don't have to understand it, it just works. Now, if I draw a vertical here, this is the perfect square in perspective. And if I do the same thing to the other side, same thing to the other side, then go to this construction vanishing point over there, this is the perfect square over here in perspective. And then if I finish it up, that's a cube, a perfect cube. A perfect cube. Remember before when I would draw these things, I would just kind of randomly put these lines in the back? Well, now I have a way of drawing perfect cubes. I'm going to do it again. Now vertical. Measure from here to here. This turns out to be about 18 inches. If this is 12 inches and this is 12 inches, this will be 18 inches. So if I measure over here 18 inches, I get a construction vanishing point right. The reason I call it right is because when you use the line of equal length here, you're to the right of your line of sight vanishing point, and you draw over here. That's how you get that distance. And then, perfect square. Perfect square. Now, if I was to go over here, and over here, and measure over here 18 inches, and you get a construction vanishing point left, to the left of this line of sight vanishing point, that would be a perfect square. Now, if I wanted to lay down a perfect square on the ground, all I'd have to do, I've got 2 points here. That is the same distance as that. This is the same distance as this. So I just erase all this stuff. And I go from there to there, to there. Whoa. Okay, that's a perfect square laying on the ground. Perfect square laying on the ground. Now we're going to move on to the next geometric shape. Well, this has parallel lines going in all directions. This only has one set of parallel lines. What we have here is a circle. Now if I have a circle like the end of this thing right here, and I put it right here in front of me, my eye level, there will be a circle. Like this. Now, if I start rotating this, the bottom of this, whatever this is, who knows? if I start rotating in this, it's going to start making another shape. And this shape is called an ellipse. So a circle in perspective is an ellipse. A circle in perspective is an ellipse. Now, if I keep rotating this, it's going to turn into a line. It's going to be a straight line. If I rotated it back until it was parallel to me, it would be a circle. Another thing that happens is if I take this and I start lowering this down, in other words, I start moving this circle down, it's going to, right here, it's going to be a really thin ellipse. On down, on down, and I keep, notice what's happening. I'm changing, I need to talk about the geometry of an ellipse. Can you see that? Yeah. You have a major axis and a minor axis. Minor axis is the short one. And as this ellipse moves down, the major axis stays the same all the way down because it doesn't get any wider. When it gets down to the station point, it turns back into a circle at that point. So if I'm drawing a cylinder, I didn't tell you this. Anytime you have a circle that's parallel to the ground plane, the major axis of the ellipse, and this is the minor axis, the major axis of the ellipse is parallel to the bottom of the picture plane, and the top of the picture plane, and the horizon line. Whenever it tips, in other words, when it's leaning like this, the major axis of the ellipse tips in that direction. So if I was to draw a cylinder here, I draw the top. Now this ellipse down here would be fatter. The major axis of this ellipse will be parallel to the bottom of the picture plane. The parallel lines here will be parallel to the sides of the picture plane. This will be an ellipse with a minor axis that's thinner than the ellipse at the bottom. In other words, this minor axis down here is fatter than the minor axis right there. Remember, as you go from here down to here, you're seeing more of the circle. More of the circle. And as long as this major axis is parallel to the bottom of the picture plane, this circle is parallel to the ground plane. In other words, it's sitting level to it. Now we're going to complicate things. Now before I do that, let me talk about drawing ellipses. I'm a little out of practice. If I take an ellipse and I draw the major axis in and the minor axis in, and I fold it in half, the top one would coincide, which means it would line up with the bottom one. And if I would fold it again, it would coincide this way. So when you're drawing ellipses, you have to maintain that maintain that look. If you don't, you've drawn an incorrect ellipse. Now it takes a lot of practice to draw ellipses. So if I had you in class right now, I would say, now start drawing some ellipses. And the first thing I would say is, don't worry about how thick it is, just make sure the major axis is parallel to the bottom of the picture plane. And I would get stuff like this. What's wrong with this ellipse? Looks pretty good. Yeah, the major axis is tipped. So I'm drawing a cylinder that's like this. And if these lines are parallel, all I'm doing is this. I'm rotating it with the picture plane. What's wrong with this ellipse? This is bad. This is really bad. So this is down here like this. In other words, the bottom half of this ellipse is incorrect. Now there's another. If I had a whole room of people, I would be getting some ellipses that look like this. I call them my hot dog ellipses. There has to be a constant arc through here. This can't be straight. Can't be straight. It has to be constantly changing. Constantly changing. I sometimes will get this. It's called a pointed ellipse. Now what happens with a pointed ellipse is a line, whether you like it or not, if I have a line that starts down through here, and I pick that line up like that, you see that line is continuing on through. But if it comes out over here, that's two different lines. This line's over here and this line's over here. A line continues the direction it's moving in. So a pointed ellipse, the circle doesn't continue. This line continues that direction, and this line here continues in this direction. And so it's not circular. So what you have to do is you have to change the direction of that line. This is the little flat. It's almost hot dog. Almost hot dog. So when you're practicing ellipses, just draw I won't say the word, a bunch. Draw a bunch of ellipses. Now, I found that if I get this kind of motion with my hand and just kind of let it land, I get that feeling. That muscle memory I was talking about earlier, when you're using the, I just walked out of the picture blank. when you're using vanishing points in muscle memory and you're using a ruler and you take the ruler away, you're kind of used to that movement. So it's good to use a ruler. Normally I don't like to use any aids in drawing, but using a ruler in linear perspective works well. Works very well. Now, I'm going to complicate the drawing of a cylinder a little more. If I take a cylinder and I rotate it like this, parallel, all the lines on the sides of the cylinder stay parallel. But if I rotate it this way, what's happening? Well, I have a set of parallel lines moving away from me. In other words, I have a set of parallel lines moving over like this. Now here's the rule. Whenever you rotate the cylinder on the ground plane, the sides of the cylinder is going to go to the vanishing point. This is going to be where the sides of the cylinder vanishes. Now if I draw a straight line right here and draw an ellipse right here, I will have drawn that cylinder on its side moving away from me. If I swing this over to here, in other words, I have a set of parallel lines going over here and draw that line, then this cylinder over here is going to be like this. That's correct. It's the minor axis of the ellipse always points to the vanishing point, the sides of the ellipse. Write that down somewhere. The vanishing point of the minor axis of the ellipse points to the vanishing points to the sides of the ellipse, of the cylinder. Now, what would happen if I rotated this until it's directly in front of me? What's going to happen? It's just going to be a circle. Anytime a geometric shape is parallel to your picture plane, it's seen in true shape and true proportion. Any other time, the minor axis and the vanishing points determine the angle that is drawn at. I wish I could say, any questions? And when I would say that, I would get about 8 people. I didn't understand a word you said, Mr. Watson. I'm going to, my wife told me to quit a little bit early tonight because we got baby on premises. But work on this. I've given you a lot of stuff to work on. And well, you know what? I'm gonna talk about the sphere. It's great. It's always a circle. The only thing that changes is, remember position in picture plane and size? It changes position in picture plane and size. The further away it gets, the smaller it gets. In fact, if I wanted to draw this circle the same size all the way back to the horizon line, I would just draw if I dropped it down to here, position in picture plane. This one's closer to me. Nothing, there's no vanishing points. One shape, it's always a circle, always a circle. But what's cool is I can draw a cylinder and well, this isn't quite a circle, but if I draw a circle right here, and I draw another cylinder up here, I've drawn a bottle. I've drawn a bottle. Remember last time I said, never outline. Always look for the basic geometric shapes and draw accordingly. In other words, if I tried to draw this bottle then that's what people do, especially in a figure drawing class. I taught figure drawing class, and I would tell them from the very first day, I says, don't outline your figure. See what the major shapes are doing, primarily the torso, and add things to the torso. See the shapes, cylinders, cubes. You can draw a circle and an ellipse and draw a line around it, a line on it. You see a figure going here, starting to happen here. Rather than I'm going to follow the forehead over there, I'm going to follow the forehead over there and get that cheek in there, and then get the end of the jaw down here, and get the back of the head over here. See, none of these things relate. So see it in terms of basic geometric shapes, and you can learn to draw it. And the more you practice it, the better your figures get. Okay, that's it. 2 minutes early.